Okay, so in this session we will see an application of classification. So in a classification, in this problem, we will have a database with many customers, and these customers are customers of a telephone company, of a communications company, and we have a number of columns describing these people. So we have the gender, whether they are old people or not, whether they have a partner, dependents. This tenure is the number of months that this person has been with the company, and then whether he or she has a phone service, multiple lines, internet service, a number of services given by the by the company. And then at the end we have the amount of the monthly charges, the total charges this person has paid to the company, and what we want to predict is whether this person will leave the company or not. That has been called churn. And we see that we have about 7,000 lines, so 7,000 entries of this database. Then there are a number of entries that are not completely full, so they may have not a number, or they have something that is not really the value that we want. So we will replace all these patterns that have problems with not a number, and then we will drop them. So we see that we have dropped 11 entries in the database. And as always, we check what is the input types. So we see most of them are objects, so we convert them to categories. And now we will start analyzing, getting acquainted with the data. So we will describe the numerical values. We only have three: the tenure, that is the number of months. So we see that they go from 1 to 72, that is 6 years, and the mean is 32, so a little bit more than 2 years, 2 years and a half, something. And then the monthly charges, the mean is $64, and the total charges, the mean is 2,000. And then the monthly charges, they go from $18 to $120. And we make a histogram, so we see that there are a lot of people here in the $18 bin, and then most of them people are around 80. And then here we have the same plot, but now separating by male and female. So we have a couple of plots for each one of them, and the same for senior citizens. So we see that the structure of the senior citizens with respect to the general structure are rather different. So if they're senior, they tend to pay more, and we will see that there is a higher probability of churning, so changing the company. And then the overall probability of churning in this database is 0.26, and we will try to get a better classifier. So this baseline is important, because a very simple classifier, if we are given a new person and we are asked whether this person will leave the company or not, we can say no, and always, without any looking at any data, and we will be correct 74% of the cases, or 73.5% of the cases. So this is an important observation. Okay, so now we will analyze whether each one of these variables, you may see that most of them are categorical, so partner, yes or no, senior citizen 0 or 1, dependents yes or no, phone service yes or no, multiple lines. We see that there are more values. We could have no phone service, no, or yes, and the same for the rest. Okay, so let's see if each one of these categorical variables are related to churning. So for doing that, we will compute these contingency tables. So contingency tables are here, and then we see whether it will churn or not, and the gender, for instance. And reminder, the overall probability of churning is 0.26, so deviations from 0.26 are significant, or should be approximately significant if there is enough evidence, but we should look for strong deviations from 0.26. And this we can make a test that is called the chi-squared test, that checks whether two categorical variables are related or not, related or independent. So the null hypothesis is that they are independent. If we reject the null hypothesis, then they are dependent, meaning that they are related. And so here the p-value is very high, so we see that there are not significant deviations from this 26.5%. And senior citizens, there is a very strong deviation from the 0.26, and if they are senior. If they are not senior, the deviation is not that large. And the p-value is very small, so we reject the null hypothesis that they are independent. So they depend, and being a senior citizen is a good predictor of churning. The same happens if you don't have a partner. So if you don't have a partner, then there is a much higher, significantly larger probability of churning. And the same if you don't have dependents. And the tenure is a categorical variable, is a numerical variable. So we see that the difference, if you have been with the company more than 37 months, the mean of so the mean of those people who don't leave the company is more than 37 months, and the mean of those leaving the company is about 18 months. So after 1 year and a half, they typically leave the company. And then churning, it is not significant. Phone service, it is not significant. Multiple lines is significant. So if you have multiple lines, it is more likely that you leave the company. And the same for the internet service. If you have fiber optic, it is more likely. Online security, if you don't have it, it is more likely. Online backup, if you don't have it. Device protection, if you don't have it, again. So we see that there are a number of services like this device protection, online backup, online security, and if you have one of these services, it is less likely that you leave the company, unless you don't have internet service. So it seems that this company has two kinds of services. One that is just a plain phone that they pay about $18 per month, and then those people with the internet. And those people with internet, the senior people tend to leave, and the people having more services, they tend to stay in the company. So that is the general message. And you can also see, for instance, the contract. If you have a month-to-month contract, it is more likely that you leave the company. However, if you have a contract of 1 year or 2 years, it is more difficult. And the same if you have a paperless billing. So if you receive your bill through the internet, then it is more likely that you leave. and the same for people paying through electronic checks, and also what is the price that makes people go, what is the average price of those people leaving the company and not leaving the company. So not leaving the company, it is about 61. If you pay around 74, then it is more likely that you leave the company, and the same for the total charges. So people who have stayed long, they have paid more to you. So those people leaving, typically we have seen that they leave after 1 year and a half, so they have paid less. Okay, so we can also represent some of this data graphically. So we see here, for instance, what is the distribution of the tenure, the number of months in the company for those people not leaving the company, for those people leaving the company. So we see that the median is, even if the mean is 18, this distribution is rather skewed. So we see that the median is around 10, and then there is a very long tail. And this is the same graph, but now for the monthly charges. So we see that people leaving the company, they have the main part of the distribution is significantly higher than this main part of the distribution for people not leaving the company. So should be noted that these boxes, they have 50% of the population. So this 50% of the population are paying significantly more than this 50% of the population. And this is the same for the total charges. Okay, so now let's start. So now we understand more or less the problem and the structure of the data, and now we will try to construct classifiers that perform better than this very simple classifier that says simply the person will not leave the company, and 73.5% of the cases will be correct. So here we will start introducing another technique that is typically used in data analysis. This is separating the data in two parts. One is training, the other one is test. There is an even more advanced technique that separates in three parts that are called train, test, and validation. Okay, so in this example, we will use a classification tree. So a classification tree again has a number of predictors, and you have to predict something. So the X will be those predictors, while what we have to predict is the churning. So in classification, Y has always to be a categorical variable. So it may have 2, 3, 4 levels, or the number of levels we want. Then the fewer the number of levels, the easier the classification problem is. But yeah, so this one is categorical yes or no, so we have only two values for that one. Okay, just to check that what we're doing. So in X-train we have the predictors, and obviously we cannot have churning as part of the predictors, because otherwise the classification would be trivial. And here we have the same. So these are the number of the rows. So this is row number 5418. So this is the description for that person, and for that person we have that this person did not drop the company. Okay, so now we play the same trick, that we expand the categorical variables into one-hot encoding, and then we name them like senior citizen 0, senior citizen one partner, no partner, yes, dependents, no dependents, yes, and so on. And they have this one hot encoding. And then we train classification trees. And all this loop, what it is doing is we are constructing classification trees of different sizes, so of different depths, and then for each one of them we are evaluating how accurate they are. So just a reminder, the most basic classifier, it has an accuracy of 76.5, so only those above this level are significantly better than a very simple classifier that makes no classification at all. And this Gini and entropy are simply two different ways of measuring the internal inhomogeneity of the nodes. We will see that a little bit later, and you have seen it in the theory. Okay, so we will take 5 as a good representative of a relatively simple tree, and the classification error, the classification accuracy is about 80%. And so we construct a tree with entropy with a maximum depth of 5, and the accuracy is 78.5, so only 2 points above the very simple classifier. And when we plot the tree, it is hard to see anything, so later we will construct a simpler tree so that we can see better. But either we plot the tree like this, or we can print it. So if we print it, then we see the kind of logic that we have. So for instance, if the contract from month to month, remember this one hot encoding. So if the contract month to month is smaller than 0.5, that means 0, that means no contract month to month, then you go this way. If it is month to month, then you have to go down to here. Okay, so you go down to here, and then so we don't have a contract month to month, then we don't have fiber optic, we don't have online security, we don't have a 2-year contract, we don't have a payment method that is a mail check, and then we will not drop the company. And if you have a mail check, you will not leave the company either. And then if you, for instance, here I'm looking for a yes, yeah, so these people here, they don't have online security, but they do have technical support. They have been in the company less than 5 months or 6 months, and they don't have fiber optic, and they have a contract month to month. And then the prediction of this tree is that they will leave the company, and you could track all the possible paths to leaving the company. Something useful when you construct a classifier is to look at the confusion matrix. So the confusion matrix is a matrix in which we show what is the true label and what is the predicted label. So you would like to have all the people distributed in these diagonal cells. So this cell is those people who will not leave the company, and you predict that they will not leave the company. And these are the people that they will leave the company, and you have correctly identified them. And you will like these two other cells are errors, classification errors, and we see here that classifying the people who will not leave the company is easier than classifying the people who will leave the company. And you commit here, for the people leaving the company, you commit a lot of errors, but still you can see it as a failure, or you can see it as a success. So those people whose intent is to leave the company, you have identified a little bit more than 50% of them. So you may try to offer them more services, or to lower the price, or to make some action so that they don't leave the company. And here, because the tree was not easy to see, we will construct a tree with only 3 levels, and now we can see better. And the classification error is the classification accuracy is 77.8, so only 1 point above the very simple classifier. And here we see the kind of structures that they have. So if the contract is month to month, if it is not month to month, you go this way. If it is month to month, you go this way. And at this point there are 5,000 observations, and 4,000 have the value 0. The other 1,400 they have value 1, and then the majority here they will not leave the company. And then, for instance, let's go for those with month to month. Then what about here? So do they have internet service through fiber optic? So these are the number of entropy. This is the entropy. This is the number of samples at this level, and then most of the people will not leave the company. And for those people not having fiber optic, and those people having fiber optic. So let's follow this path, because there is a yes here. So you don't have the month-to-month contract, you don't have fiber optic, and then at this point we wonder whether you have been less than 16 months in the company. And those people here, the majority are have the class yes. So there are 1,700 samples here, and the majority will leave the company, unless a majority, there is a very relatively half people, but unless you have been with the company more than 16 months. If you have been more than 16 months, the majority are no. But still, we see that 500 people will not leave the company, but still 300 will leave. And here 200 people will not leave the company, but almost 600 will leave. So yeah, this is the kind of decisions that the decision tree are making, and these mixtures of 200, 600 or 500, 300 are what the entropy is measuring. So you try to minimize the entropy of each one of the nodes. Okay, so now different kind of classifier. So these classification trees can work on any kind of data. So either they are continuous or discrete. So tenure is continuous, while online security is discrete. But linear discriminant analysis is a classification technique that only can work with continuous variables. So we will take the tenure and the monthly charges as the two only continuous variables that we have in the dataset, and we will construct a classifier based on those. So here we have a graphical representation of that. So we have here the tenure in months, we have here the monthly charges, and we have the blue points are people who will leave the company, red points are people who will not leave the company, and we feed a Gaussian to each one of these populations. Linear discriminant analysis, the Gaussian has the same variance for both, so these two ellipses are the same, and then we calculate the frontier at which it is more likely that you belong to the blue class than to the red class. So here, these people here are more likely to leave the company. So what are they? They are people who are paying a lot and have stayed shortly with you. So if you stay more time or you don't pay so much, then you will not. The most likely event is that you don't leave the company. And here is the confusion matrix. We see that this linear discriminant analysis, the classification accuracy is 1 point above the level of the simple classification. It is more or less of the same complexity or the same accuracy as this one, that is much more complicated classifier. So there is not a single way of constructing classifiers, and you may try to find for each problem what is the best way to do it. Then we have quadratic discriminant analysis, and the quadratic, what we allow is that the Gaussians have different shapes and different covariance matrices, but the classification is mostly the same, and the accuracy is not printed here, but it is roughly the same as with the linear discriminant analysis, because we don't see much of a change here in the structure of the populations. And the confusion matrix is this one, and what we see, for instance, here, the classification of the people who will leave the company is worse than what we had before. So before it was more or less half-half, now it is more like 2/3, 1/3. And that's it.